let's go back into the agenda and let's check the well deviations with this AlanaPy script. This is another subject. So, but I'm going to do it here, just below what we've done. I'm going to order it in a further time, and let's create this this new section called well deviation. And what we are going to use in this case, I'm going to use the both wells. So instead of using the demo server, I would need to use the open server. Okay, I'm going to copy this section, this block, and paste it all over here. I'm going to re-execute this line. I'm going to paste my token of the open server, and I'm going to declare this data source as the master class. It's going to load. There you go. The connection established successfully. This means, let's remember what this means. This means that if I access data already stored in this function, in this class, sorry, such as well type, master dict. If I execute it, I have the wells that we previously in previous sessions we saw, for example, the YPF wells of Vaca Muerta, and someplace here inside all these wells, we would have the both fields. I don't see them, but they are here. Here they are, F1, F11, F12, and so on. Why? Because the data available regarding the well deviation, we only loaded the both data. So, okay, excellent. I'm going to, this was just for you guys to see it. Instead of using the figure, instead of using the Plotly graph object, because this is the scatter plot, I'm going to use a 3D version of a visualization. In this case, I'm going to import Plotly Express. And here, I'm going to first call a function that is stored in the data source class called get well deviation. If I run it, oops, what's get well deviation? Interesting. Yes. This is a work in progress that I'm currently doing. So instead of importing the AlanaPy commonly, this is in its local form. This is a work in progress I'm currently doing. So I'm going to import AlanaPy. I'm going to copy this name, copy, rename. I'm going to copy AlanaPy version 2 local. There you go. If I run it, there you go. And if I'm going to assign this, my API, the instantiation that I did, yes. Alana local. I remember that. No, it's without capital letter, I think. Or is it with capital letters? Let me see it. No, it's not with capital letters. Excellent. I instantiate only the data source class. Let's run it again. It's not opening the AlanaPy script. It's opening a local script that I have, and the connection successfully established. And if I run now the get well deviation, I would be able to see a data frame, or in this case, a dictionary. The response comes in a dictionary form, in a list of dictionaries in this case, that has several columns, such as meters developed, true vertical depth, the displacements north-southing, displacements east-westing, the inclination, the azimuth. Let's change this into its correspondent data frame form, PD from pandas. And it's going to be in a much more sleek looking way. But I forgot to assign it as a variable, in this case, deviation. This data frame, let's print deviation head and the 5 first elements. There we go. It's making the request again. I executed again this line, and as you can see here, you have the columns that I said, as well as inclination, the azimuth, the dogleg severity, the vertical section, a rate turn value, the rate build, the negative true vertical depth, latitude and longitude if the data has it, and in this case we have as well the section and the WLFK. We need to change this WLFK form into a much more readable form. Instead of having numbers, let's have well names there. So I'm going to do a couple of lines of code. In this case, I'm going to call the well master dict that has well names and its correspondent WLFK. I'm going to create an inverse dictionary, and then I'm going to replace that those values, but I'm going to create a well-named column. If I run again the DF deviation data frame, I have here the well name. Excellent. And then I'm going to now we're going to create the function that will plot the trajectory. In this case, let's remember that when we upload a survey of a drilling survey, we have just a couple of points that every time the driller stopped the bit, take measures, those measurements were stored with this data. Of course, there's a lot of much more data, but in order for Alana to store it, we would need to focus it into the matter that we wanted. In this case, this was only the data that we wanted to store. So we upload this information into the Alana server, and let's create a function that will plot those points, right? I created here the plot trajectory 3D one variable function that it's going to receive a data frame, and it's going to receive as well a string for hue, color. And for example, here I'm using the scatter 3D. I'm plotting the X, the northing, southing displacement, as well the other easting, westing displacement, and the negative true vertical depth, and the string that I want to hue. I'm going to run this function, and in order to do so, I'm going to call it, but just for you guys to see all the information stored in the server, I'm going to create a loop that will plot all the wells in order with its surveys. In this case, I'm going to create, I created a DF temp, a data frame, a temporary data frame that has only that well, and it's going to plot that data frame, that temporal data frame. And in this case, I'm going to plot the dogleg severity. Okay, so in fact, I'm going to place as well print. I'm going to use this form of printing. I'm going to well, and I'm going to print well. There you go. I'm going to run it, And for example, the F11, well, it's been plotted. There you go. And this is the dogleg severity of each point in the survey measurement. We are taking advantage, let's remember, of Plotly to see each point with its correspondent dogleg severity. In this case, we can see that this is a multilateral well. Let's see the F1_C. This is as well another multilateral well. A couple of multilateral wells, actually. We have the stem here and a couple of multilaterals. This F12, it's only a directional well. It only has one path. And the F15 has this form. Something happens here. As you can see, the dogleg severity, it's almost close to 0. So this means that either there's a problem with the measurement, or the data is missing. Well, it's not that the data is missing, it's that when the process of uploading was done, this was the value that the data was given to us. So let's see the F5, which is as well another directional. The F14, another directional, but this is a very steep curve on this trajectory. Yeah, we are going to plot, instead of the dogleg severity, let's plot the azimuth. It's going to take a while, but there you go. This is the azimuth of each trajectory stored in the Alana server, the Alana open server. Let's remember that these are the bulb wells. So as you can see, all of this, if we want to store the wells that we want, we can actually give the server all the information that we want to create these workflows. And in a couple of minutes, we can access that data, and we can develop very robust workflows of analysis and optimizations as well. So let's go back into the agenda.